I'm the co-founder of fast.ai, which is trying to make deep learning more accessible and easier to use. And then I'm also director of the Center for Applied Data Ethics at the University of San Francisco. And this is something that we just announced a few weeks ago, so it's very new. So I want to talk about a few different types of, and when I say bias here, I know bias has several definitions. I'm referring to unjust bias. And so I'm going to talk about some different types, go through a few case studies to illustrate them, as well as debunk a few misconceptions about bias. And then towards the end, there'll be a few steps towards solutions. The first case study is facial recognition and predictive policing. So there was a research study last year that came out from Joy Balanwini called Gender Shades that evaluated commercial computer vision products from Microsoft, IBM, and a large Chinese company called Face++. And it found that these products performed worse on women compared to men, and worse on people with dark skin compared to people with light skin, having the highest error rates for dark-skinned women. And so to give one example, IBM's accuracy on light-skinned men was 99.7%, compared to dark-skinned women, 65.3%. So this is a huge difference in accuracy, and this is a commercial product that was released. There was a follow-up study studying Amazon that found similar results. A separate study from the ACLU looked at facial recognition software that's already being sold to police in the US and is in use, and it incorrectly matched 28 members of Congress to criminal mugshots, and the Congress people matched disproportionately included people of color. And I should also note that IBM is also selling technology to police for use. And this is an area that is virtually unregulated in the US, and so there's really kind of no oversight or regulation on what these technologies do or how they're being used by police, which is really concerning. So from here, I want to talk about, so I mentioned that there are different sources of bias, and it's great that bias is getting, unjust bias is getting more attention within machine learning and within data science, but you kind of quickly realize that you need to get a little bit more specific to address it. And so this is a great paper from Harini Suresh and John Gutag at MIT that came out earlier this year. They also wrote a nice blog post kind of offering a taxonomy of different types of bias and where they enter the modeling process. And so in the case of this facial recognition performing worst on dark-skinned women, this is representation bias. We can guess that the data sets that were used by these companies had few dark-skinned women in them. And it's also kind of part of a broader problem, evaluation bias, which arises from the fact that benchmark data sets spur on a lot of research in machine learning. And so in some ways, this is a good thing. We have these benchmark data sets that are really well studied and we can compare results on. But it's a problem when there's bias in those data sets that it's kind of then propagated at scale. And so we see this with all the facial data sets that were popular 5 to 10 years ago, had very few dark-skinned women in them. So for instance, IGBA, only 4% of the images were of dark-skinned women. And I don't know if you've heard ImageNet, which is, I think, one of the most well-studied computer vision data sets in the world. 2/3 of the images in it are from the West. And so we're starting to see the repercussions of a ton of research has been done on this very Western biased data set. So a step towards addressing this is to create more representative data sets. And this is something that Joy Balanwini did as part of her work, and that's available at gendershades.org. And this is a data set created with pictures of politicians from many countries around the world. Okay, so second case study is the Compass recidivism algorithm used in prison sentencing. And I want to check who's heard about the Compass recidivism algorithm. Yeah, it's gotten a lot of attention, which is good. This is an algorithm that can be used at a few points in the criminal justice system. One is determining who has to pay bail. Currently in the US, about 1 million people are in jail because they're too poor to afford bail. This is prior to even having a trial. And then it can also be used in sentencing decisions and in parole decisions. And in 2016, ProPublica did an investigation that determined that the false positive rate for Black defendants, this is people rated as being a high risk who do not go on to reoffend, the false positive rate was 44.9%. So this is really high. In contrast, it was 23.5% for white defendants. There was a study from Dartmouth earlier this year that found that this software is no more accurate than random people on the internet. They compared it to Amazon Mechanical Turk workers and got similar accuracy for predicting risk. And again, this is a private proprietary algorithm the makers of are earning money off of. Also, the Compass software is it's a black box that takes over 130 inputs, and it performs about the same as a linear classifier on 3 variables. And one of the places this was challenged was in Wisconsin, but the Wisconsin Supreme Court upheld its use. And so it's outside of the scope of 30 minutes today to fully go into this, but I really encourage you to watch Arvind Irani's tutorial on 21 definitions of fairness if you're interested. He's a professor at Princeton, and it's a really great overview of kind of how we define fairness and what the implications of that are. So something I want to highlight from this case study is a common misconception I hear, and that's someone pointed out race was not an input variable to the Compass algorithm. So even though it had these very racially biased results, race was not being input. And I often hear people say, like, oh, we're not measuring race or gender, so we must be okay, we're not biased about them. And that's not the case, because machine learning excels at picking up latent variables. That's typically why we're using it. And so even if you're not measuring race or gender, they're typically latently encoded in a lot of other variables. And even a YouTube executive made this mistake in the New York Times a few months ago. So returning to our kind of taxonomy of what type of bias is this is historical bias. And historical bias is a fundamental structural issue with the first step of the data generation process. And it can exist even given perfect sampling and feature selection. And so this is something, previously we saw with the facial recognition that having a more diverse and more representative data set would help address the issue. Here, increasing the data set that this was trained on would probably not have an impact because all the data is going to have bias from kind of the structure of the US criminal justice system. It's really, really baked into it. Another thing I want to highlight that this example illustrates is the issue of feedback loops, which show up a lot in data science and in machine learning. And so the idea of a feedback loop is that whenever your model is controlling the next round of data you get, the data that's returned quickly kind of becomes contaminated by your algorithm. And so I think this is hard for many of us kind of coming from a more science background, whereas if you're thinking of data science like, oh, I'm observing the world and making these observations, it can kind of not acknowledge how much we impact the world with the software we build. And this can occur with predictive policing. And so the idea with predictive policing is, you're trying to predict which neighborhoods will have the most crime, and so you send more police officers there. But then you might get more arrests as a function of having more police officers in that neighborhood, which could then feed back into the algorithm to send even more police there. Suresh Venkatesubramaniam, who's a researcher working on this, has said predictive policing is aptly named. It is predicting future policing, not future crime. So I think that's a good description. I think we also see this some with recommendation systems. Ostensibly recommendation systems are trying to predict what content you may like, but they're determining what content you see, and they're helping determine what content becomes popular. And so they have a lot of power in that sense and are very vulnerable to feedback loops. So historical bias is a hard one to address. One step towards trying to do better with this is to really work closely with domain experts and with the people who will be impacted by the tools we build. And so a positive example of this is Christian Lum, a PhD in statistics, who works at the Human Rights data analysis group organized a workshop together with a former public defender, Elizabeth Bender, who's now a staff attorney for the New York Legal Aid Society, as well as with an innocent man who was arrested and could not afford bail and was held on Rikers Island, Terrence Wilkerson. And Elizabeth and Terrence are able to provide a lot of insight into how the criminal justice system works in practice that's really valuable and important. And this is something I studied math and computer science in school, and I really like thinking about kind of abstract, logical systems that are very clean, but that's not how things work in the real world. And so it's really important to recognize how our software kind of plugs into these complicated and messy human processes. The third case study I want to look at today is online ad delivery. And this is an important one since online ad delivery is what is powering kind of most of the major tech companies and a lot of the internet in terms of the business model. So LaTanya Sweeney is a professor at Harvard where she's director of the Data Privacy Lab. And she noticed several years ago that when you Google her name, and she's the only LaTanya Sweeney, you get ads from a background check company that say, LaTanya Sweeney arrested, implying that she has an arrest. And she has never been arrested. She even paid the $50 to the background check company to confirm they have no arrest listed. And she tried Googling some other names like Kristen Lindquist and got much more neutral ads that just say, we found Kristen Lindquist. And so being a computer scientist, Dr. Sweeney studied this systematically. She looked at over 2,000 different names, and she found that Black names were disproportionately likely to have these ads suggesting that the person had a criminal history, even when they didn't, and white names had the more neutral sounding copy on the ad. And so the companies involved said that what was going on is Google lets you A/B test different versions of ads, and that they had put both versions in for every name, and then based on what people were more likely to click on, that's the ad that kind of mainly got shown after the A/B testing. And so this is something where kind of the racism of users and being more likely to click on ads suggesting that a person with a Black name has a criminal record led to this very wrong outcome. This issue of bias in online ads is a recurring issue that shows up in a lot of ways. Recently in April, research came out that when you post ads on Facebook, they get served to very skewed audiences. And so the researchers weren't specifying the audience they wanted to see the ad, but some of the job ads they posted got shown to 90% men. Housing ads, it's interesting, they kept the text the same and changed the picture between a white family and a Black family and got very different results of who was shown the ad. And so this is really concerning, and this is something where the researchers were not trying to discriminate. There have been a number of previous cases where people could use Facebook to explicitly discriminate, including a large number of companies posting job ads that they only want young people to see, including many tech companies. And so kind of want to pause and highlight that kind of many of these examples we've talked about now include job ads and housing ads, as well as our criminal justice system and policing. And so these are areas that really impact people's lives. And they're also, I would say, areas about human rights and civil rights. And many AI ethics concerns are actually about human rights. I like the framing from Anil Dash that there is no tech industry anymore because tech is being used in every industry. And when we refer to the tech industry, that's kind of too broad to be meaningful anymore. And it's more helpful to kind of think about the specific verticals that we're referring to. And I think particularly in areas such as housing, education, employment, our criminal justice system, voting, and medical care, we need to think about what human rights and what civil rights do we want to protect. Sorry, I'll pause. I see a few people taking photos. So now I'm going to kind of return to this idea of how it's great that the word is getting out about biased data, but when you want to address it, that concept quickly becomes too generic to be useful. because different sources of bias have different causes and are going to require different solutions or different steps to try to mitigate them. And again, I'll highlight this paper has a wonderful blog post accompanying it, and that's something I would love to see more of people writing blog posts about their academic papers. So, well, we talked earlier about representation bias, evaluation bias, and historical bias. Now I want to cover measurement bias. This comes from a great paper by Sendil Mullainathan and Zayed Obermeyer. But they looked at a lot of electronic health record data and said, let's predict what are the factors that are most predictive of who's likely to have a stroke. And this could be used to prioritize patients at the ER. And so they were looking at a large number of factors, and the top most predictive one was prior stroke, which makes sense. Second was cardiovascular disease. That also seems very reasonable. Then was accidental injury was third, which is surprising, followed by a benign breast lump, colonoscopy, and sinusitis. So what's going on here, right? Like, we don't have to be medical doctors to realize this doesn't seem expected as the result. You want to pause and kind of think about why this might be. So the issue is that we haven't actually measured stroke, which is about a region of the brain being denied new oxygen from the blood flow. What we've measured is who had symptoms, was able to go to a doctor, received the right test, received an accurate diagnosis. That's what we have measurements of. And there are a lot of factors that influence this, such as who has access to medical care, who can afford their copay. There's racial and gender bias baked into how doctors treat patients and even recognize symptoms. Who can afford to take time off of work. So there may be a number of cultural factors of who ends up with this official diagnosis of stroke. And so what this data set had done is kind of just picked out who uses healthcare and who doesn't. And they refer to this as utility. They're people that utilize healthcare a lot, and they'll go in if they have sinusitis or an accidental injury, and so they also go in when they have a stroke. But then there are people that don't use healthcare as much, and so they may not be recognized. And this is an example of measurement bias. And typically, our measurements are proxies for what we truly care about. And so that can lead to surprising results. So this is some of the types of bias they list. I'm not going to get into aggregation bias in the interest of time today. But I do want to elaborate a little bit more on historical bias and where it comes from. So a large number of studies have been done on this. I'm just going to mention a few. These are all linked to from this New York Times article by Sendil Mullainathan. And again, these all come from research studies that were statistically significant. So one is that when doctors were shown identical files, they were less likely to recommend a helpful cardiac procedure to Black patients than to white patients. And there have also been studies on Black and Latino patients receiving less pain medication than white patients for the same ailments. When bargaining for a used car, Black people were offered initial prices $700 higher and received fewer concessions. Responding to apartment rental ads on Craigslist with a Black name elicited fewer responses than with a white name. White state legislators were less likely to respond to constituents with Black names, and an all-white jury was 16 points more likely to convict a Black defendant than a white one. But when a jury had even just one Black member, the conviction rates were the same. And so this is really pervasive, and I just want to illustrate that kind of whether you're working with sales data or medical data, political data, criminal justice data, it's likely that there is historical bias in your data set. And I should also mention this is kind of like ongoing bias. Gender bias. These are a few studies, and I linked to them in a post I wrote several years ago called "If You Think Women in Tech is Just a Pipeline Problem, You Haven't Been Paying Attention." This is by far the most popular thing I've ever written. But one is that when men and women pitched the same idea, they were reading a script, male voices were rated as more persuasive, logical, and fact-based than the exact same pitch from a woman. Job applications with male names were rated as more competent and hireable and offered a higher starting salary than the identical application with a female name. When men and women negotiated a job offer by reading identical scripts, women were rated as being more difficult to work with, men did not receive that penalty, and so on. And so this kind of raises a question that I hear a lot, which is, why does algorithmic bias matter? So I've kind of just shown you, like, humans are really biased too. And this is, how, or one of the main ways bias can end up in our data. But why does algorithmic bias matter? Why are we all here to discuss it? And so there are several reasons for this. And one is that machine learning can amplify bias. So here's a study by a group at CMU. And they were looking at, I think, like LinkedIn job descriptions and predicting the job title from them. And their data set, 14.6% of the surgeons were women. And in their predictions, they ended up with just 11.6% of the true positives being women. And basically, there's kind of an asymmetry between false negatives and false positives that leads to these imbalances being compounded. Another issue, so this comes from a quote from a news article from a town in California where an IBM dashboard is being used for predictive policing. And one of the city officials involved said, with machine learning, with automation, there's 99% success. So that robot will be 99% accurate in telling us what's going to happen next. This is completely false, and I think you all know that this is not how machine learning or how computers work, but this is a common misconception that people have outside the field about the accuracy of computers and of machine learning, and it can be very, very harmful. And kind of gets into this broader issue that algorithms are often used differently than human decision makers, and we can't treat them just as kind of plug and play interchangeable. This is because people are more likely to assume that algorithms are objective or error-free. Algorithms are more likely to be implemented with no appeals process in place or no way to surface the mistakes that are being made. Algorithms are often used at scale, and algorithmic systems are cheap. And all of these fit together. So I think in many cases, algorithmic systems are being implemented as a cost-cutting measure. Offering appeals or being on the lookout for mistakes would be more expensive, and I feel like that's part of the cost that's been cut, although it has a huge human cost to do so. But as a result, algorithmic systems can have a different impact than human systems. And so I'd encourage everyone to, sometimes these debates kind of devolve into, like, let's debate what the least terrible existing option is, but to really think about how can we develop less biased ways to make decisions in general. And so kind of in conclusion, the answer to this question of why algorithmic bias matters is because algorithms and humans are used differently, because machine learning can amplify bias, not just encode it. Feedback loops, which we talked about earlier, about how you can kind of end up creating outcomes, and also that technology is very powerful, and with that, I think we have a responsibility to use it well. And so in my last few minutes, I want to start talking about some steps towards solutions. These are very complex and hard problems, but I think the one thing I hope you would maybe do after today is to return to your workplace and analyze a project or a data set, to look for sources of bias and to try to understand the project better and what the risks are. So I have some questions to ask about AI, and these can be used for projects you're working on yourself, or as well as technology being sold by others. And I just this year added a new first question, which is, should we even be doing this? And so this is something I think we often kind of skip over in a project and kind of just start analyzing it without spending enough time on what technology should we build and what should we not build. And I need to credit Oz Keys. They tweet at Farbandish on these topics and have said a lot of good things that have kind of inspired me. But as engineers, we tend to respond to problems with, what can I make to solve this problem? And sometimes the answer is not to make or build anything. And so as an example, there have been, I think, at least 2 studies now of people trying to see if they can determine someone's sexuality from pictures of their face. And it's, very debatable that these studies actually do that. But either way, it's a harmful thing to do. There are countries where being gay is illegal. You can really be kind of putting someone at risk by trying to build technology like this. There was also research done in the past few years on determining people's ethnicities. So here's a study identifying Chinese Uyghurs, Tibetans, and Koreans. More recently, a million people who are Uyghur, which is a Muslim minority in Western China, have been placed in internment camps, and this has been facilitated through surveillance. So this is a, I think, very dangerous line of research. And then I do want to note IBM's partnership with the Nazis. This is a photo from 1937 of Adolf Hitler meeting with the then CEO of IBM, and that this is a project that we don't analyze like, oh, IBM should have structured it differently or had a different database schema, but just really this is a partnership they, I think, should have ended before they did. And so, yeah, I encourage you to really kind of spend time on that kind of what should we even be doing and how can our work be weaponized. Beyond that, to recognize what bias is in our data. All data is biased, and so it's not a question of if, but how, and it's important to understand how, and that doesn't mean that you can't work with it, but you need to understand how that bias was gathered and what biases live in it. Can the code and data be audited? What are error rates for different subgroups? I want to highlight with Joy Balanwini's work with gender shades that I showed earlier, it's really significant that she looks specifically at Black women as a group. If she had only been looking at women versus men, light-skinned women would have brought up the accuracy. If she had only been looking at light skin versus dark skin, men would have been bringing up the accuracy in the dark skin category. And so it's significant that she looks specifically at dark-skinned women. What's the accuracy of a simple rule-based alternative? We saw this with the Compass recidivism algorithm of, why are they using this proprietary black box when it's not even more accurate than a linear model? And then how will mistakes be surfaced and handled? Oh, and also, very importantly, how diverse is the team that built it? And I think that having more diverse teams and teams that are representative of the people that will be impacted is really crucial. And so just kind of my brief message about diversity, and I've written a lot about this topic, but is to start at the opposite end of the pipeline from what people typically think about, which is our workplaces. 41% of women working in tech end up leaving the field compared to just 17% of men. And a meta-analysis of 200 books, studies, and articles on this found that they're leaving because they're treated unfairly, underpaid, less likely to be fast-tracked than their male colleagues, and unable to advance. I also want to note that many diversity initiatives end up focusing primarily on white women, which is wrong. Women of color are facing many additional obstacles and should be the focus. Only half of Black and Latino graduates with computer science degrees from top universities are hired by major tech companies. And so some of this is kind of a starting off point to thinking about how we can increase diversity in the workplace. Yeah, and so and I should also highlight, I spoke earlier about point 2, the working with domain experts and those impacted. To address it, also advocating for good policy, and realizing that this is an ongoing process that kind of never is fully done. If you're interested in these topics, I blog about them at fast.ai. You can go to Topics, AI and Society. And then also, I was a part of launching this new Center for Applied Data Ethics. And our opening event is tomorrow evening. If you're in downtown San Francisco, it's free. You can find the meetup page. And we'll be having Deb Raji as our speaker, and she was the co-author on the gender shade study looking at Amazon's technology. So be sure to check this out if you're interested. Yeah, and then I think I'm at time now, but I'm happy to take questions outside afterwards.
Yeah, we have a minute or two, but
okay.
If there's one question, would that be all right?
Yeah.
Anyone have a question? Oh.
Yeah, so how could I increase diversity in my workplace? I mean, how could I, in the interviewing process, how can I fight my unconscious biases?
So I wrote a blog post called How to Make Tech Interviews Less Terrible. where I talk about this some, and in it I acknowledge tech interviews are terrible for everybody, and they're tough because it takes time to do it well. But there's some advice there on kind of developing very specific rubrics and kind of analyzing what you're looking for to be more consistent.
We'll just do one more. You lucked out.
Hi, Rachel. Thank you for your time.
Oh, thank you.
This was really, really good. So I have a couple of friends doing the data science masters, and they're very appreciative of everybody's work. And they're very interested, they're very intrigued about where this is going, right? Talking about ethics exclusively.
Yeah.
Where do you see this Center for Data Ethics in the next, let's say, 15, 20 years?
Oh, wow.
In hopefully a different Silicon Valley in many ways, and hopefully similar in many ways.
Yeah, I mean, I'll be honest, I had not been thinking 20 years in the future. I really hope it's less necessary at that point. And that'll be through the efforts of many people and many centers. But yeah, I hope that a lot of these ideas become more kind of incorporated into company processes and into training for data scientists and into laws and policies that are relevant. So yeah, I would hope that it would kind of maybe be less needed then and more absorbed into everything. Yeah, thank you.
Okay, thanks everybody for coming.